So now in this video, we're going to take a quick look at a demonstration practice circuit that we can make with the 74HC00. So the 74HC00, 74 is a series of integrated circuit. There's a whole bunch of different types. HC is high-speed CMOS. That's the type of transistors in there. Ultimately, it determines what the output can do to make things simpler. And 00 is the circuitry within the integrated circuit. So it's two input. Each one of them has two inputs. There's four of them though. Quad NAND gates. So we looked at AND gate in the last video. Now we're going to look at NAND gate. You can see we got this jumper to the negative supply as well as this trim pot turned down to the negative supply. I can move the jumper to the positive supply. Output is going to stay high right now, and no matter where I move that, because we have a low input here, we need to get all inputs high in order to get the output low. So it's the opposite of the AND gate. With the AND gate, we needed all inputs high, and this is picking up stray signals in the air, so it's bouncing all around. You don't want to pull up or pull down resistor to give it a solid voltage when you are flipping between them. But in any case, if that was important. But in any case, there you can see, now we have two high inputs and a low output. So that's the NAND. If any of them are low, any input is low, then the output is going to be high no matter what. We need every single input high in order for the output to be low. And again, we looked at the AND gate in the last video, so hopefully you saw that, or you're already aware of the AND gate. And there's a number of reasons why you would do this. You can combine these NAND gates to make any other logic gate. You can make all kinds of circuitry just by combining NAND gates. But for now, we're going to keep it simple. We're just going to light LEDs and be in a high-speed CMOS version of this integrated circuit. And generally with the 7400 series integrated circuits, you have an output that can provide enough power to light LEDs. So we could work with up to 25 milliamps of current, either sourcing that current or sinking that current with one of these logic gates. So two of them, we could get 50 milliamps by using 25 milliamps at the output for a total of 50. But that's it. Limit it to 50. So if you're going to use all four, keep it lower to about 10 milliamps of current. So when it comes to integrated circuits that are doing logic functions, all kinds of other stuff, they will have what's called a truth table. So when the output state depends on the input of usually multiple, but not always, inputs, then you will have a truth table like this where you can look that up. So low means, basically negative supply here, or a zero. And so the output, will be high. It'll be as close to 5 volts as it can be. It may not get all the way to 5 volts. I don't remember. It's been a long time since I looked at the data sheet for these components and measured them as well. That's important. So yeah, any low input, ground, basically, we have a high output, 5 volts. If we get all of the inputs high right there. So there's only two here. So this would just keep getting longer if there was more inputs, but only this bottom one here, where they're all ones, will give you a low output where it is 0. So hopefully that makes sense. There's 4 of them in the integrated circuit because it's a quad. I always look up the data sheet. Other NAND logic gates may have different pin layout. So there's one up there. I have 1 out of 4 there, but I'm actually using 2, number 2. So you may see 1 4 if there's 2 of these in a circuit. One will say 1 4, one will probably say 2 4. You don't have to use the ones that they show there, but it may make it easier to know if there's a lot of wiring, which one is which. When if you swap the number on the component versus the sheet, it will get confusing if you have a lot of stuff being wired to them, which one you're going to. So with complex wiring, I suggest use the same number that you got there. But we will move to the integrated circuit. So yeah, I always have to power it. I didn't show that at the schematic. I'm using 5 volts. I don't know the voltage range. It's been a long time since I looked at the data sheet. But right now the red LED is lit up, and we have more current than we did lighting up the red LED with the AND gate, which is interesting. And now I'm going to set both inputs high, and there's the blue LED. again, we have more current than we did with the AND gate, which is interesting. So, not sure why. Obviously, they're outputting a different voltage, most likely, or some other problem. We probably don't want to leave these other pins floating. That may be another issue. So, in any case, we're not going to dwell on that too much. There you can see the LED. So, the red LED, 220 ohm resistor order, doesn't matter. Current is limited. You know, series components have the same amount of current flowing through them as every other component in series with them. It doesn't go high in one spot and low in the other. The resistor ultimately sets the current in this case based on the voltage across it. So you can see negative there. The red LED is lit up, so you know that current is flowing from the resistors to the negative supply. Yeah, so you know that current is flowing through the LED that way. You need the long lead towards more positive, short lead more negative, as always. We have the blue LED, and so now we're working positive there, coming to the top pin and then down. So long lead anode, short lead cathode. If you put it back in, it won't light up. And if the LED is not lighting up, everything looks right, there's a good chance it may be backwards. But yeah, there's the output, and there you can see to the negative supply when the blue LED is lit up. So again, to get a low output, we need both inputs high. And when this jumper is in the air, that's picking up stray signals right there. So again, you'd probably want either a pull up or pull down resistor to avoid that. Not going to go into detail on that in this video. But also with the trim pot there, you can see this is even worse, I think, than the AND gate. I can get it. I believe the output might kind of be off or something. Current might be flowing through the two resistors and LEDs. So yeah, this isn't a Schmidt trigger version. This isn't really meant for when voltages are around the middle range right there. But still, this is a good, unless you kind of want this flash, you could have a slowly change in voltage right there to shuffle the LEDs if you really want to. But in any case, I think I covered everything that I need to cover. Again, I'm not sure the voltage range. Always check the data sheet for more information. My videos are just kind of to get you an introduction. So you'll see a lot of my diagrams. I say consult the data sheet. Always consult the data sheet and learn as much as you can about the components. They all have their little quirks and stuff, especially depending on what type of transistors are used. So you know a bit, you know, if you really get into the designs, when it's a 7400 series integrated circuit, there's also a 4000 series integrated circuits. But the 74 series has a couple letters that gives you more information on the transistors basically in there. As far as you using it, you're just kind of concerned about what the output is able to do. And so that varies with the letters. But the next two numbers, that is what is the circuitry in the integrated circuit is. The logic gate or many other types of circuitries that you can use. And a lot of them have a truth table where the you can see how the input state affects the output. And they're not all just ones and zeros. There may be some other factors as well. But that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.